So this is the homework section for 3.2, and I'm going to start by talking about problem 17. And what I need to talk about first is this line y equals x cubed. And it says, sketch the graph of x to the n and each transformation. Well, x cubed looks something like this. If we graph it, we know it looks something like this. At 0, it's 1. At 1, it's positive 1. At negative 1, it's negative 1. At 2, it's 8. At negative 2, if we cube negative 2, we get negative 8. So it looks something like this. So there's my graph of y cubed. Now we just need to figure out what these transformations do in each one of these. And it's a lot like what we did in chapter 2, but we just have to recognize what each one of these are. So for letter A, what we first have is x minus 4 cubed. So this is almost the same except for this minus 4, and the question is, what does this minus 4 do? Well, you would think, since we're subtracting 4 from x, you would think, well, if you subtract 4 from an x, you would go left. But any time you are subtracting from an x before this main operation, it's actually the opposite. You're actually moving this whole graph right 4 units. So this whole graph here is getting shifted to the right 4 units. So it's going to look something like this. So there's my graph shifted to the right 4 units. And because it's inside to the cube power, that's when you move it left to right. Now, for letter B, it says f of x equals x cubed minus 4. Now this time we cube it and then subtract 4. So it's after you cube it, then you subtract 4. So this is a change, but you're moving up or down, and since you're minusing it, up and down doesn't work backwards. So that's a result of moving down 4 units. So if we talk about where this is going to move, you're going to take this whole graph and you're going to shift it down 4 units. So it's going to look something like this. So there's your new graph there. For letter C, our function is asking us to scale it by negative 1/4 and then cube it. I should say cube it and then scale it by a negative 1/4. So the question is, what do we do with this negative 1/4? Well, we already have these y values here, so we're going to scale them by a negative 1/4. So what that means is that this is going to be reflected because of the negative. And it's going to be compressed, or kind of shrunk, by that factor. So it's going to be going at a much smaller rate than it would before. So we're going to see here that it's going to go a lot slower up. It would go a lot slower up this way, but since we're reflecting it as well, we need to make sure it is reflected across the x-axis like this. So that is a reflection and kind of a compression because it takes it and makes it smaller. I didn't write anything perfectly to scale, but that's kind of how it would look. Now for letter D, it says we want our function to look like this. X minus 3 cubed, x minus 4 cubed, minus 4. So the question is, what do these do? Well, we just got done saying that this was right and this one was down. Now we're doing both. So we're moving it right and we're moving it down. So it's going to start right here. So it's going to start right there and it's going to scale up. So there is my graph with all of the transformations. Now for 23, it's asking us to describe the left and right hand behavior of the graph. So what we have here for 23 is this function 5 minus 7 halves x minus 3x squared. So all we need to know is we need to know two things. What is the leading coefficient? And what's the degree? And that will tell us how it behaves. Well, it's not written in the right order, but I can tell what the leading coefficient is. It's a negative 3. So the leading coefficient is negative. The degree is the exponent you see with the leading coefficient, and that's even. So we know that if it's an even degree and a negative leading coefficient, then the end behavior has to look something like this. Has to look something like that. It doesn't really matter what the shape looks like, but we know that it goes towards negative infinity. So it keeps going down and it doesn't stop as x goes towards positive infinity. It's going towards negative infinity as x goes towards negative infinity. So again, we don't necessarily worry about what it looks like because all it's asking for is what it behaves at as it goes towards positive and negative infinity. That's all we're worried about. So now I'm going to talk about exercise 35, and it says to find all the real zeros and determine the multiplicity of each zero and the number of turning points in the graph and use a graphing utility to graph the function. We're not going to do all of that. I'm just going to talk about the couple of things here. Specifically, I'm going to look at this first function. It says x squared minus 36. It says to find the zeros. So I'm going to, if I'm going to find the zeros, I need to say, well, where is it equal to 0? Now there's a couple ways that you could solve this. You can solve it with square roots. You can solve it by factoring as well. So what we have here is something that looks like this. Now we have two zeros. It's either 6 or negative 6. Now, each 0 only appeared once. So it has a multiplicity. I haven't talked about this in class, but it has a multiplicity of 1. So each one has a multiplicity of 1. Okay? So you might ask, what is an example of something that has a multiplicity of something other than 1? Well, I'm going to show you one right now. If we look at something like 38, and I know I didn't assign that, but if you look at 38, we have this function f of x equals x squared plus 10x plus 25. This is also factorable. So I'm going to let 0 equal that because I'm finding the zeros. The two numbers are 5 and 5. So I can write it like this, but I don't have to. Okay, I can write it as x plus 5 times x plus 5. But again, I don't have to. There's only one answer, and it's x plus 5 squared. So my answer is negative 5, but this has a multiplicity of 2 because there's 2 of them. It's actually a 0 that's repeated. Now, in terms of what this looks like on a parabola, you know, this first one here, we have the graph hitting the axis at negative 6 and positive 6, and it goes like this. With this one, we just have a graph that hits the x-axis at a negative 5. And that's it.